Hi class, so today we're going to be going over transformations of absolute values, and this is going to be able to help you understand what the parent function looks like for an absolute value and how to identify characteristics of these absolute value graphs without having to graph them. Okay, it's super cool and it's going to be very helpful in preparation for your Unit 2 exam. So let's get started. First, let's talk about the absolute value itself. So we know that the absolute value equation is f of x equals the absolute value of x. This is that parent function. And we know that the graph, when we graph this, we get this shape here. And we know this because we've been graphing these for a while now, right? We get this V shape. And so in discussing the domain, we know that the domain is going from negative infinity to infinity, which would be all real numbers. And we know the range, so from the bottom up, okay, we are going from 0 to infinity. So we could say, oh, that should be a parentheses there. We could say this as y such that y is greater than or equal to 0. Okay, that's for our interval notation, and set notation. The x-intercept, so that's where is it crossing the x-axis, right? And so here's my x-axis, and we're touching it here at the point 0, 0. That's my x and my y. My y-intercept, where we're crossing it here at the y-axis, well, it just so happens to be the same point. So I'd be at 0, 0. That's my x and my y. The maximum number of roots or zeros. So what I want you to think about roots or the zeros, these are also the number of solutions, right? And when we've been solving absolute values, we know that we have the positive case and the negative case. So we have a maximum number of 2 solutions, or 2 roots or 2 zeros. So now let's talk end behavior. So as x is approaching negative infinity, so as I am going forever in the left, negative infinity. So I write that here, as we're going forever in the left, my graph is doing what as far as y is concerned? Okay, this is, we'd be going forever up to positive infinity. Okay, as I am going to as I'm going to positive infinity, this would be my right. Okay, as I'm going to the right here, my graph is also going up. My y is going up forever in infinity. And this is going to be a continuous function as there's no breaks or holes or jumps or anything like that in absolute values. So this is just a real big deep dive into what the parent function of an absolute function looks like. Okay? So now let's get started with the transformations. So with the transformations, we have some rules here. So we'll see if the graph gets shifted to the left or the right, up or down. And so what you might see something like that, okay, is if we have f of x equals the absolute value of x plus 2. And you'll see here that while it's a plus 2 inside the absolute values, this is going to shift 2 units, okay, to the left. Okay, it's always the opposite of what's happening inside the absolute value. 4 shifts of left and right. Okay, for f of x equals the absolute value, and let's say x minus 3. This case would be 3 units to the right. We have a shift of 3 units to the right. Okay, remember it's the opposite of what's happening inside that absolute value. So if it's a plus 3, we go 3 to the left. If it's a minus 3, like we see here, it's 3 units to the right. Okay. For the next case, if I see the absolute value of x and I have some plus 4 on the outside, this is going to be a shift up. So we'd say 4 units up. And on the last one, if I see something like this as the absolute value of x minus 5, we would see that minus 5 is on the outside of the absolute value, so that's going to be 5 units down. Okay, so the up and down students do pretty well, and I know you guys will do well with this as well. Just remember the shifts left or right is going to usually be opposite of what you see inside the absolute values. So a plus 2 would be 2 units to the left, while a minus 3 would be 3 units to the right. All right, so now let's talk about vertical stretches. So if I see a case, okay, and we're talking about numbers that are bigger than 1. So bigger than 1. So if I see a case of f of x is equal to 2 absolute value of x. So we have this 2, this leading coefficient. This is going to stretch our graph. So this would be a stretch by 2. Okay. If we see something between 0 and 1 leading our absolute value, so that's something like 1/4 or 1/2 or 3/4 or 2/5. If we say something like that, where we have f of x equals 2/5 absolute value of x. 2/5 is a number between, okay, so I'm going to write that here, between 0 and 1. Okay, this will cause a compression, so you'd say compress by 2/5. All right, and for our last one, guys, if we see a negative leading our absolute value, if it's right in front of the absolute value, okay, this will cause a reflection. So an example of that would be f of x equals negative, let's say 2 absolute value of x. So you would say, like, yeah, we've got a stretch by 2, but it's also reflection. And why is it reflection? Because we have this negative here. So let's do a couple of practice problems together. I've got some steps here that I'd like for you all to follow. And it says here, please read the function from left to right. This will help set up your transformations. So the first thing you want to do is identify any negatives. This causes a reflection. So let's look at number 1. Do I have any negatives? No, no negatives, so no reflection. We're good there with number 1. So I'll put a little check mark here in red. We're doing this problem in red here. Okay. Identify a coefficient before the absolute value. In other words, do we have a number before the absolute value? No. So there is no stretch or compression. Identify any addition or subtraction in the absolute value. So we're looking at inside, and we do. This will cause a shift right or left. And so remember, it's always the opposite of what you think. So if I see a plus 2, this would be a shift 2 units. Now it's a plus, so we do the opposite of what we think that is, so it'd be 2 units to the left. We got that. And identify any addition or subtraction after the absolute value. We don't have any of that. So this is done. We just see 2 units to the left. Okay, let's go ahead and do number 3. We'll follow the same steps. Identify any negative before. I don't have any negatives here on number 3, so there's no reflection. Identify a coefficient before the absolute value. Again, it's the number right before the absolute value of x. There's nothing there. Identify any addition or subtraction in the absolute value. So I see inside the absolute value, I have just x. There's no addition or subtraction, so we're good there. All right. The next part, identify any addition or subtraction after the absolute value. So I do see this plus 2 here. So that plus 2 on the outside will do shift 2 units. And because it's a plus 2, it'll be 2 units up. And that was our last step. So we are done here. All right, let's do number 5 in blue here. Okay, and I apologize, let's check this off here. Let's do number 5 in blue. So first identify, do we have any negatives? Nope, no negatives, we're done there. Identify coefficient before the absolute value. Ah, look, check it out. I've got that 2 there. So that's going to be a stretch, right? It's a positive number greater than 1, so it's going to be a stretch by 2. So that happens there. Identify any addition or subtraction inside my absolute value. It's just x. So there's no addition or subtraction. And there's no addition or subtraction on the outside of the absolute value. So we're done here. We just had a stretch by 2. And let's do number 7 in purple. Let's follow the steps. Do I have any negatives? I have to identify a negative. Oh, look, check it out. So I have a reflection. Okay, so we got that. Do I have a coefficient in the front? No, I don't. It's just a negative. We've already identified that. Do I have any addition inside? No, I don't. It's just the x. Do I have any addition or subtraction on the outside? No, I don't. Okay, so we have just reflection as far as the transformation on this graph. Okay, so tomorrow, guys, we will be doing, actually in the next lesson, we will be doing more examples like these. It's fairly easy. As long as we follow the steps. So please make sure that you review this video again if you need to and finish the assignment on Teams that aligns to this homework. All right, thank you guys, and we'll see you next time.